This program is designed to introduce you to fault isolation on the 767 electrical power system. Fault isolation is provided by built-in test equipment, commonly referred to as BITE. The Bus Power Control Unit, or BPCU, and the 3 Generator Control Units, or GCUs, are individually responsible for isolating fault conditions and storing the results in non-volatile memory. This data is stored during the flight and retained for display while on the ground. Fault information is stored for the previous 7 flights. On the front of the BPCU is the BITE instruction plate, 2 rows of segmented light-emitting diodes for display, a push-button bit switch, a guarded periodic test switch, and a guarded reset switch. The alphanumeric display on the BPCU is made up of 24 characters that read out messages in the English language. These messages describe what faults have occurred and which area of the system contains a problem. The BPCU is located in the main equipment center on the E2-4 shelf of the E2 rack. Power is supplied from either the right DC bus or the battery bus. To interrogate the BITE memory, press the bit switch. This starts a sequence of readouts on the status of the systems. The first system to be displayed is external power. If no faults were recorded during the last flight, OK will appear in the readout window. Then the BPCU will automatically sequence to the left generator power system. Again, if no faults have been recorded, OK will appear in the readout window. The automatic sequencing will then interrogate the right generator power system, and then the APU generator system. After the system's status has been displayed, the message will read, last flight, 00, end of data. After 2 seconds, the display sequences to, for previous flights, push now. This display will hold for 15 seconds. Pushing the bit switch within 15 seconds, the test sequence for the next previous flight will be displayed. If the switch is not pushed, the display is terminated. The following is a typical example of a check of a reported in-flight fault of the right generator system. Go to the BPCU and push the bit switch. This will activate the unit and start the system's check. The first system to be interrogated is the external power system. No faults have been recorded. OK is displayed. Then the left generator power system is interrogated. No faults have been recorded on this system either, and OK is displayed. Next, the right generator power system is interrogated. A fault has occurred in this system, and the display indicates it was an under-frequency trip. This information will be displayed for 15 seconds. Then the display will change automatically and indicate the faulty LRU. In this example, the IDG failed. Record this information in your maintenance records. After 15 seconds, the automatic systems check will continue. When the display indicates, for previous flights, push now, push the bit switch and check the memory to verify that all flight faults have been recorded in your maintenance records. Now, the guarded reset switch can be pushed to clear the memory. At this point, all indicated maintenance should be performed on the system. In this example, it was required to change the IDG on the right engine. When the maintenance has been completed, an engine start will be required to power the system so the byte units can electronically perform a system's checkout. With the engine shut down, return to the BPCU for systems checkout. Press the bit switch and allow the unit to automatically sequence through the systems to verify the repair. If there are no faults within the systems, OK will appear in the display window after each system check. The third switch on the BPCU is a guarded periodic test switch. This switch is used during scheduled periodic maintenance checks to determine the operational status of the BPCU and the 3 GCUs, plus their related electronics. Pressing the periodic test switch initiates a partial end-to-end system check of all non-operating channels and displays failures not apparent to the flight crew. System sequencing and fault information is the same as when the bit switch is used, with the addition of byte codes that identify faults within the control units. As we have seen, the function of byte is to provide as much correct system troubleshooting information as possible in order to quickly and correctly identify failures. It minimizes the unnecessary removal of LRUs and provides verification for completed maintenance.